So let's talk about some of the modifications to the course logistics. Well, first, a few principles that we're going to observe for the remainder of the semester. The first principle is none of us signed up for this. We did not sign up for the sickness, not for the social distancing, not for the sudden end of our collective lives together on campus. We did not sign up for an online class. I am aware of that. I did not sign up for teaching remotely. But we have to make do, right? We are going to try our best to make this work and make sure that you learn this topic as well as possible. The second principle is, when in doubt, the humane option is the best. We are living in the time of a pandemic. So we are going to be cognizant of that. We are going to prioritize supporting each other as humans. We are going to prioritize simple solutions that make sense for the most. And we are going to prioritize sharing resources and communicating clearly. The third principle, we cannot just do the same thing online. Some assignments are no longer possible. Some expectations are no longer reasonable. For example, active class discussion is going to be harder here, even though I'm going to try to encourage it. Some objectives are no longer valuable. Principle 4, we will foster intellectual nourishment, social connection, and personal accommodation. For this purpose, we are going to emphasize on asynchronous instruction. So even though we are going to go through a live lecture now, these lectures are going to be recorded, and some of the lectures will be pre-recorded to accommodate those who may not have a good internet access to join us during these live sessions, and those who may be in different time zones, those who may have small children at home and cannot remain connected in the live sessions for the duration of the class. There will be optional synchronous discussion to learn together and combat isolation. I'll tell you more about this in a couple of slides. The fifth principle, we will remain flexible and we will adjust to the situation. Nobody knows where this is going, and we will have to adapt. And I'm aware of this one particularly. Everybody needs support and understanding in this unprecedented moment. So these are some of the principles we are going to observe throughout the course, and the remainder of these slides are merely guidelines. We may decide to change some of the details of the logistics as the situation develops. Course delivery is going to change. I'm going to try to pre-record most of the lectures. This lecture today is not going to be a pre-recorded one. We are actually going to go through the lecture today, and there's a particular reason for it. We are going to start talking about a relatively complex topic, and I need to make sure that you get the chance to ask your questions as I deliver the lecture. But I'll try to reduce the number of live lectures as much as possible. I'm going to try to keep them keep the number to a minimum. What are we going to do during class time if the lectures are going to be pre-recorded? There will be tutorials. So Shreya, our TA, is going to deliver tutorials. In these tutorials, she will go through a problem set and their solutions via Zoom. The first tutorial is going to be early next week, I believe. We are going to announce the schedule. This is to accommodate the midterm. We are going to talk about the midterm as well. The class time can be used as office hours as well and for general discussion. Other than the class time, I'm going to be available every day from 12 p.m. to 1 p.m. through Zoom. I'm going to share a link on Blackboard for these office hours. These office hours are, of course, accessible to my students in other classes as well. So you may have to wait for a while before your turn comes up. If you need to schedule an alternative meeting with me and a meeting with me at an alternative time, all you need to do is to email me. As for course communications, there is a Slack channel, but many of you are not registered or in that Slack channel. So I'm going to send you the invitation again. Just a moment. If you check the chat box. Here's the invitation link to our Slack channel. All you have to do is to click on it, register, and you will be in the Slack channel. I will check the reach of our Slack channel right after this lecture. I'll send out a group message and I will ask every one of you to confirm that you are on that Slack channel. What's the purpose of the Slack channel? It's for you to discuss or ask questions among yourselves, and I will be monitoring the channel as well. So if you have a quick question you need to ask me, you can do it through Slack. Now, grading. As you're aware, you now have the option to choose between a pass-fail grading scheme or the traditional letter grades. You have until May 5th to decide. And by then you will have a great proportion of your grades, and you should be able to make your decision in an informed manner. What's a grading scheme for this class? Well, the class projects, the projects that the implementation projects, programming projects for each topic comprise 25% of the total grade. There will be module quizzes. These were previously known as assignments. These will constitute 10% of the total grade. There is a course project or a term project. I will tell you more about this in a couple of slides. This will be 25% of the total grade. The midterm exam, which is going to be towards the end of next week, I'll give you more info as well, is going to be 15%. And there will be a final exam, which constitutes 25% of the total grade. What are the remaining topics for the rest of the semester? We are going to talk about Markov decision processes today. Next week, we are going to cover reinforcement learning. The week after, we are going to cover probability and Bayes nets. And we'll continue this discussion on the 16th of April. For the next topic is going to be machine learning. We are going to dedicate 2 weeks to machine learning. We are going to go over the basics of machine learning as well as an introduction to neural networks and deep learning. And the very last lecture, this one is not going to be in the exams. This one is not going to be assessed, but is necessary for anyone who wants to do any work in AI, is going to be on AI safety and security. Now, the midterm exam. We've been waiting for the midterm exam for about a month now, right? This time we have a fixed date. We already have the questions. It will be a take-home exam as promised. It will be released on the 2nd of April, next week this time. And it will be due, so your solutions, your answers to the exam questions will be due on the 9th. The week after. You will have an entire week to work on the midterm exam. It's open book, but try not to consult among each other for the solutions. If you have a question, just reach out to Shreya or myself. It's not going to be a difficult exam. What's going to be covered in this exam? Everything up to and including reinforcement learning. So the definition of rationality and introduction to AI, search, CSPs, Markov decision processes, and reinforcement learning. How are we going to take the exam? It will be most probably a solve by hand. So you're going to write your solutions on a piece of paper, take pictures with your phones, compile it as a single PDF, and then submit it. We are also exploring the option of making the exam completely online, just like the assignments. If we figure out how to do it properly and in a sound and robust manner, the exam will be online. You will know which option, which one of these two, which case is true next week this time. What about the final project? So you will need to complete a final implementation project for this course. This project can be on anything related to AI. It's up to you. You just have to pick an idea that you're interested in, write a proposal on it. I have more information on the proposal in the next slide, I believe. Yes. You will need to write a proposal on it. Then you will need to implement it, come up with a working demo, and create a dedicated GitHub repository for the project and add some documentation. You will also need to write a report. This, similar to midterm, is for another course. I will remove it from the slide after the lecture. There needs to be a poster as well. So you will create a poster. You don't need to print it. All you have to do is to fill in a poster template that I give you. It's going to be a summary of the report. So the submission for this poster is going to be either a PDF file or a PowerPoint file, not a printed poster. And you will also need to record a presentation and a demo of your project and post it on YouTube. If you wish to keep the presentation private so that others can see it, YouTube offers us the unlisted option, so you can make your video unlisted so that others cannot find it through search or YouTube recommendations. How are we going to grade the presentation? Well, the total grade for this presentation is going to be 5%. 3% of it comes from me and 2% is from peer review. When's the deadline for the final project? It's going to be on May 10th. So you will need to select a topic, select an idea for this project and write a proposal. The deadline for this proposal is April 9th, 2 weeks from now. The proposal will be a written document constituted of the following segments: a problem statement. What is it that you're trying to solve? What is it that you are implementing? You need to describe your approach. What techniques are you going to use? Are you going to use any data at all? If so, where are you going to get the data, or how are you going to collect the data? Then you need to give me a list of deliverables. What are you going to deliver to me, and how can I make sure that you've delivered on your promise? At the end of the day, when I'm grading your final project, I will refer to your proposed list of deliverables for assessment, and I'm going to check and see if you've delivered everything that you say you're going to deliver. In the proposal, you might want to do some preliminary analysis as well, if you wish. This is optional. You can try to implement a proof of concept or a preliminary demo just to show that you've started working on this and you have a good grasp of what needs to be done. This is really important. You need to schedule a meeting with me to discuss and get approval for your idea. This will be a one-on-one meeting. It will be through Zoom. To schedule it, all you need to do is to send me an email. I'll send you a link which allows you to automatically schedule the meeting in my free time. The deadline for this meeting is going to be April 9th, but I recommend that you meet with me as soon as possible, because towards the end, I may not have as much free time as now to meet with you. And if I ask you to change anything in your proposal or your idea, it's better to learn about the need for change sooner rather than later towards the deadline. Now, here are some ideas for the final project. This list is not comprehensive. This list is only a suggestion. So you can work on reinforcement learning. You can create reinforcement learning agents for game playing, like Atari game playing. I think there's something in chat. I can't see the chat box from here. If you need to ask me anything, raise your hand. I'll call on you, and then you can use your microphone to ask me.
Is it an individual or the group project?
It's going to be an individual project.
Okay.
So for everyone, it's going to be an individual project. Thank you for that question, Anujit. The other idea is reinforcement learning for autonomous vehicles. There are lightweight simulators for autonomous vehicles, and you can implement reinforcement learning agents that do autonomous driving and obstacle avoidance. This is really interesting. You can implement machine learning models for disease diagnosis. You can create an agent. It can be a search agent. It can be a neural network. It can be a reinforcement learning agent to play a particular type of chess called the Baruch chess. I'll give you more information on this and the relevant instructions on Blackboard. You can work on feature-based reinforcement learning to solve the Rubik cube. You can work on comparison of search-based and reinforcement learning agents in solving the game of Snake. This is the same Snake that many of you are familiar with from the days of Nokia phones. Implementation of multiple tic-tac-toe playing agents in a tournament setting. So agents playing against each other. And you can, of course, propose your own idea. Very well. Any questions about anything we've talked about so far, about the logistics, about the project?
Professor,
you need to raise your hand first. It's really important. All right, go ahead, Venkatesh.
Professor, a working demo is mandatory?
Yes. You will need to try to create a working demo. If you fail to do so, you will get partial credits instead of full credits. Other questions? So for those of you who joined a bit later than the beginning of the class, if you need to ask a question, there's a button at the bottom of the participants list. The button says raise hand. If you click on it, I'll get a notification and I'll call on you so that you can unmute your microphone and ask your question. So are we clear on the logistics? Are we clear on the requirements for the project and so on? Okay, if you have any questions about this, you can ask me anytime, either during the lecture or later on. I need to show you something else. So if you go on Blackboard, let me share my screen with you. So if you go on Blackboard, you will see that it's been restructured. We have our traditional folders here for lecture slides, notes, projects, and so on. But from now on, everything is going to be grouped in modules. So there's now a module called Markov Decision Processes. When you click on it, you will see files and items related to this module. Right now we have the lecture slides of what I'm going to cover today, as well as the lecture notes that you need to study before next week. We'll add an assignment here in the coming days, as well as this recording, and probably a quiz. For next week, you will have a similar module on reinforcement learning, but the project will be posted here as well.